record, share screen. All right. You'll see me hopping back to this document. This is where I typed my word problems. And this software that I use does not save them from class to class. So I have to just copy them out of this document and then I'll paste them into the one that I write on because it doesn't save. So there you go. Number 1 out of 5. These will not take long to copy down. So get a copy down. I have changed my approach to teaching this, and I honestly am pretty happy with the decision. When you have the benefit of a lot of years, then you start to really have enough data to figure out what's the best way to do something. And I think the vibe today should be pretty good. So anyways, I'm going to stick with what we've been doing, obviously the 4-step process, and I'm going to stick with just declaring a couple of different variables. I am going to get away today from the contextually specific variables. Just because like if it's like alligators and crocodiles, A and C make perfect sense, right? But in a case like this, we're probably just going to stick with the good old generic X and Y. But as long as we declare at the beginning, then we're safe because everyone will always know what we're talking about, right? If you own the X and the Y, then it's there. It's like documented. X is this and Y is this. So step 1 is, of course, as it always has been, to declare. So let's just go ahead and go with, let's let X equal the larger number. And I understand that it's not addressed in the problem. Like it's like, how do you know one of them is larger than the other? Well, I know that personally because the difference is 15. And if the difference of two numbers is 15, then they literally are 15 numbers away from each other, which means they're not the same, which means one of them has to be bigger, right? So I'm going to go ahead and let X equal the larger of the two numbers. And then, of course, you probably know this, but let's let Y equal the smaller of the two. Yeah. So we decided earlier today that that usually takes about 10 seconds, and that's not bad, right? It's for a basic expectation, 10 seconds. All right, now we're going to get to, this is our first of 5. I think the first example is a little hard just because it's new. And then the second, third, and fourth tend to be kind of the same level. And then the fifth is the hardest of them all. So the goal for today is to get you to feel more comfortable, to get you to not walk away from this and say, like, we don't want you to leave high school and say, I suck at word problems. You know, I hate word problems. Like, we want you to get a level of comfort from this to where I'm not scared. Like, if you ask your parents, they probably will not think fondly back on word problems, right? People remember that about high school. So hopefully I can get you to feel a little bit differently about it. They're not that bad, right? All right, so there's 2 pieces of information in this problem. Each piece of information is going to produce an equation. I'm going to color code them throughout the lesson. So the first one, and it's probably hard for you to color code, I understand that. But the first one is there in yellow. And it's a statement that says something that I need to know. It says that the sum of the numbers is 53. So the first thing we need to talk about is our math words, our nerd words. Do you guys remember what the word sum means? It is. Earlier, someone said it means the numbers make 53, and that is a completely unacceptable thing to say. What does make 53? And Braden nailed it. It means that it's addition. It means numbers add to make 53. What's our nerd word for subtraction? Difference. What's our nerd word for multiplication? Well, times is pretty generic, but multiply is pretty generic. Do you know the word starts with a P? Product. If it ever says the product of two numbers, that means they're multiplied together. Anyone know the nerd word for division? Nope. It's quotient. Very good. So as you see words like that pop up from time to time, you just have to know, okay, they said the sum. I know that that means the numbers add to make 53. So let's get to it. The one that I have underlined in yellow, says that if I add the numbers together, I get 53. Could you take the declaration over there and then turn it into an equation?
Yeah.
What is it?
X plus, oh,
Go ahead.
no. Well,
Stop.
yeah.
Just go. Quit doubting yourself. Go.
X plus, no, X minus 15.
Please look only at what I have underlined in yellow and do not doubt yourself.
53 equals X plus 5.
Yeah.
Yeah.
You marched right into it, and I thought, my God, he's going to get it on his first try. And then you started to talk yourself out of it. Listen, you know what you know. You know that what I have underlined in yellow says, in plain English, two numbers added together make 53. This is what it looks like in non-plain English. Two numbers added together make 53. Let it be as simple as you think it is. Now, I'm going to underline in green the second chunk of information. You can't get through these without multiple chunks. If all I knew is they added to make 53, this would be a really bad problem. Like they could be 1 and 52. They could be 100 and negative 47. I mean, they literally infinitely many things, right? What is that second, that green one? Summer?
X minus y equals 50.
I agree. So the difference means to subtract. So that green thing in plain English means that two numbers, when being subtracted by each other, equal 15. And there we have a system of equations. And this one, as it turns out, is pretty simple because it presents itself as a very bare bones, they don't get any easier than this level 1 elimination problem, right? So we're going to use substitution a lot throughout this lesson, but not this time. I mean, I'm not going to take this and say, no, thank you. I'm going to say yes, please, and thank you. So I'm going to prep this one as I always do. When it's time for me to add two equations together, I put my line. That's my commitment line, like I'm going in now. And when I add these two equations together, I'm deep in step 3 now, right? When I add these equations together, how many x's do I get? Right. How many y's do I get? And what is 53 plus 15? Good. And then if I divide both sides by 2, what did I just figure out? That x is 34. And it's not important right now, really, I don't think. Although if you were to watch, you can't because I deleted it, but my defective recording from earlier, I'll just tell you what happened was I accidentally had x as the smaller number and y as the larger. And when I wrote my equation, my student that sits there, I won't use his name because it's not fair when they're not in this class. He said, like, how could that be a smaller number? And he was spot on. I boofed it. But at this point, the only reason I might want to look back is just to make sure that I feel like, does that feel like it would be the larger number? And I say, well, yeah, it does. So, but anyways, I say I'm deep in step 3. I'm not worried about the words and all that right now. I'm in the midst of doing the math. And how am I going to find the other number? What's that? You can listen. There's a very mathematical answer to this question, which is perfect, which I will never say is not good. And the correct thing to say is you plug it in. That's what I've always done, and it will always work for me. If I know x is 34, there's absolutely nothing stopping me from just putting it right there at the end of that red arrow, right? However, not everything has to be a math problem. Let's say I stood up right now and I told you, which I don't, so I'm a teacher. Let's say I told you I had $53 in my pockets, right? So x plus y equals 53. And if I open up this pocket and said, I have $34, could you figure out how much I have in the other pocket? And you wouldn't need a math equation to do it, would you? You'd go, well, it has to be 19 bucks. Because if I got 34 over here, 19 over here, add those together, what do you get? 53. So not everything has to be super mathy. Some people actually solve step 2 or the second variable in a case like this with just pure unadulterated common sense. FYI. But anyways, to make it official for your notes, if we put 34 back up in there, the yellow equation now says 34 plus y equals 53. You know, make it official, subtract 34, and there's your poof, your 19, just like that. And step 4 never goes away. Okay, so don't ever let it go bye-bye. No one is interested in your X and your Y. You are, because you wrote it. Someone is interested in the answer to the question in the big, fat, red box. That question. So I answer it for them and I use English and I try to use good English, right? So here we go. I could say, what do you want to do first, the larger or the smaller? Don't care. Okay, so let's say that capital T, the larger number is 34. The smaller number is 19. And because someone asked me for both numbers, which will not be the case in every problem, I'm going to put a box around that as if to say, you asked me for the numbers, there they are in a box. Yeah, that would be okay. Yep. We good? Nothing to it, right? All right, let's do example number 2. Go back to this.
Oh, this one's good.
Yeah, you're not going to find much struggle. And listen, I will tell you this because I want you to always know that I'll be honest. When we get to the age problems next week, I'm telling you ahead of time that those are hard, okay? Like, not trying to scare you, just giving you a fair warning. Because they're going to be questions like, in 9 years, Mark's age will be 4 less than 3 times what Hannah's age was 2 years ago. It's like mind explodingly challenging. You're not going to feel that today. Okay. You guys are good. We've had such a good year and your skills are good. You're good readers. The only one today where you might feel a burn is the last one. But if you feel like this, what's he setting me up for? I'm nothing. You follow the 4 steps, okay? Declare your variables, write your equations, do your math, answer the question. You're going to be just fine. Now, this time I'm going to take a different approach with my variable declaration. And the only reason I'm going to do this is because of the way the numbers are named. They're not specifically named as the larger and the smaller. So I'm going to kind of stick with the vibe of the problem. They're named as the first number and the second number. So I'm going to go ahead and go with that. So I'm going to say let x equal the first number. And of course, then I would let y by default equal the second. If you're a math person and you've already read, you already know who's larger and you know who's smaller, right? Like it says literally that the second is 9 more than the first. So we already know that we could replace second number with larger and first number, but I just don't, no need for that if you don't want to. So variables are declared. It's time to write a system. And again, I'm going to break it into colors for you just so we understand that like there's always going to be 2 chunks. Each chunk is going to provide an equation. Like give me an equation. There, got the yellow one. Let's get the yellow one out of the way first because it certainly there's a little bit more meat on that bone. But like Parker said right away when he saw it, like this is not bad, right? There's nothing to it. So let's take that sentence and dissect it and actually write a math problem out of it. What will it say?
Well, no, it's
Stop. You just start and then you question yourself. Someone just roll it off the tongue. Just read that sentence and then write me an equation. Remember, bless you, that equations have to have equal signs in them. Yes, and I'm going to go another direction just because I want it to match the sentence. But yes, I want to read my sentence. I want to read my English. And every time something occurs to me, I'm going to put it down. So here it goes. I'm going to put a little box around this and then I'm going to delete it. The second of two numbers is. Ready? Here it goes. The second of two numbers is. Sometimes people get confused when it says the second of two numbers, and they think that this number 2 has something to do, like, should I add 2? It's like, no, it's just the second number is. And that's what that says, y equals. And then after the is going to be the other side of the equation, which says 9 more than the first. And here it goes. 9 more than the first. Piece of cake. Now, this equation is the cream puff. Are you kidding me? Like, anytime someone gives me one of these, I'm like, yeah, thanks a lot. I appreciate that. Their sum is 29. What does that mean?
X plus y equals 29.
Yeah, their sum, there it is in green, is 29. This is not a level 1 elimination problem, right? What is screaming at us here? They're not lined up, first of all, so I probably don't want to do elimination, quite frankly. But I mean, think about the other method, substitution. I know he gets pooped on a lot, but what do we do first in substitution? What do we do first in substitution? We get a variable by itself. And if you're seeing what I'm seeing, y is already by itself. So I'm ready. I don't even have to move anything to do substitution. The red box is like, I'm right here. Okay. I'm going to use substitution for a problem like this 100% of the time. You could move some stuff around and make it right for elimination, but like, why, unless someone told you had to, why would you do that? So where am I going to put the red box? In Y, right there, where the little arrow's pointing down low. So my new green equation is going to say X plus where Y used to be equals 29. And as it turns out, that's a completely unnecessary set of parentheses. Mathematically, what's going to go in there? Just the X plus 9. And because it's a plus, a quantity, the parentheses, like I said, they really don't need to be there. So at this point, I could take my eraser and just go, you guys are, you don't need that. Now it's basic math. What's X plus X? Right. So I have 2X plus 9 equals 29. Next step. 30. Next step. Yeah. But the fact that I heard the number 38 tells me I still need to get better at my job. For the 1058th time, when you move something over an equal sign, you have to change its sign. So when I move the 9, I subtract the 9 and I get 20. And then I divide by 2 and I get X equals 10. And I'm still not really in word problem mode. I'm kind of deep in the forest of step 3. And now that I know X equals 10, where should I put that 10? In the box. I love that 3-word answer. If we're doing substitution and you say anything other than in the box, I'm just not doing you right here. In the box, in the box, in the box, in the box, right? That's what substitution is best at. And if I put 10 right at the end of that purple arrow, what's 10 plus 9? And just like that, we now know that Y equals 19. So let's write our sentences and move on to example 3. The first, oh wait, you know what? Hang on a second. Let's go back and read the question.
What is more than the
Good. I almost missed this earlier, and I was like, God, don't tell me I'm gonna have to record again 6th hour. Geez, I should read my own math problems. This question is only asking for the larger number. Do not give all the information if it's not called for. Like, so you could cross some of it out or box some of it up specifically. That's fine. But I'm just going to answer the dang question. Which one of them is clearly larger? So I'm going to say the larger number is 19. That's what was asked for. That's what I'll provide. 2 down, 3 to go. You still feel good? These next couple are very largely similar, I think. Tomorrow will be a work day. I don't know if I said that or not, but there you go. And again, I'm choosing to call them by these names because that's what they were given to me as. Had it been referred to as the first and the second, I'd go down that road too. Then later on, we can differentiate between who's larger and who's smaller. Good. All right. Step one is in the books. We got our variable declaration, and now it's time for step two. And step two is to, again, decipher math sentences from English sentences. So let's start with the longer of the two, the yellow one. And again, this isn't set in stone, but again, we're faced with understanding what the power of that word. And I'd say probably 8 times out of 10, that word's going to mean something. What does is get replaced with? It's going to probably be your equal sign. And as you'll see in the next example, that's not always true, but is generally is going to be like, so this is this. And so like that can be my middle of the road equal. So I can put an equal sign if I wanted to, just like right here. Now, what does it say to the left of the equal sign? So what will I put there? Good. So the larger of the numbers is. There you go. And now let's press on past the word is, and it says 2 less than twice the smaller. What's that going to look like as a math problem? It's this is a common mistake. Don't write this down, but this is close. You nailed the 2 less than part, but let me highlight a word for you. Yes. So instead of putting x equals y minus 2, we have to do it like this. We have to say the number is, yes, 2 less than twice the smaller, 2 times the smaller. So whenever you see twice, it means, double times 2. I try not to use the word thrice because people think it's not a real word and they think I'm just being silly. But so I usually will say twice if it's 2 times, but if it's any more than that, I'll say like 3 times, 4 times, 5 times. But thrice is a pretty dope word, by the way, if you want to start throwing it into your vernacular. It is. It's nice, isn't it? He did it not once, not twice, but thrice. Yeah. All right, so that's the hard one, if you want to call it that. Then I don't think that was very hard, right? Now the cream puff is this one. Ooh, we've seen this before. Their sum is 37. What's that?
X plus Y equals 37.
Yeah. And again, what's jumping off the page?
Substitution.
Yeah. Can you imagine if someone overlooked that and then like moved the 2y and got it all lined up for elimination? Like, what are you doing, man? Like the box is ready to go. X equals something. I can just take that something and just put a dang box around it and go, done. And where are we going to put the contents of that red box? In place of X, right? And the other equation, so I'm going to just follow the little red arrow here and just go boop right there. So my new green equation is actually going to say where X used to be, I shall put a 2y minus 2. and then put the plus y equals 37. And again, I'll put parentheses here just so you can see that's where x used to be. Not anymore. Then we got some basic math to do over here on the left-hand side. Let's combine us some like terms. How many y's we get?
41.
And are you guys, you're not scared? Let's add 2 to the other side while we're at it. What do we get? 39. Let's divide by 3. What do we get? Oh, yeah. And where is a great place to put that? 13. In the box. So follow the big long purple arrow here. It goes whoop, right there. What is 2 times 13? And what is 26 minus 2? So we can now say that x must equal. In reading the question that you copied into your notes, what were we asked for? Both numbers. So like Xander said, if you just want to say the numbers are 24 and 13, honestly, in the context of how it's asked, that's not a crime. I'm going to stick with what I've been doing and just say it like this. The larger number is 24. The smaller number is 13. Put a box around that because you're presenting an answer as what you were asked to find. Like you asked for the numbers, there are the numbers. 3 down, 2 to go. You still good? Still awake? That water tastes good out of that Stanley. Yeah, I had not had myself on recording yet making fun of Stanley Cups, and now I do. Rats. Rats. I'll have to edit that out. No. No, don't say it. I don't want to. No. I'll make fun of the Stanleys some more and I'll do it on recording. I'm not scared. All right, we'll plow through this one a little bit quicker because honestly, this one made its way in only because I thought, I don't know really what my inspiration was. I probably could have cut this lesson down to 4 and killed this one. But let's get her done. Maybe someone did the last example and they're like, well, kind of did okay. Well, good. Then here's another practice for you. So let's do it. Let's copy it down. Let's declare our variables and let's press through and get to the last one. And then let's be done for the day after. No, we've got one more after this. This is just basically the third example. Essentially, again, it is really. And honestly, if anything, maybe I put this one in here because of this word right here. There. Maybe my mind early this morning was like, okay, we have a less than. Let's do a more than. I don't know. Either way, let's muscle through so we can say we did this all. All right, let's get to it. You got the problem copied? You got your variables declared? Let's write an equation. To be consistent, color coding, again, the more complex of the two is certainly the one that's underlined in yellow. But we're not scared. What's it going to start out as saying? X equals. And by the way, X equals literally takes out, ready for it? All of those words. Like that's the larger of numbers, the numbers it is. That's a lot to take out. So I'll get rid of that though. What comes after the equal sign? Yeah, good. And just watch the pen if you could be so kind. Just watch the construction of it. 4 more than. Notice the way I didn't put 4 plus. I left room and then did +4. Anything that involves the word then should go at the end. More than, less than, fewer than, put it at the end. 4 more than is +4, and then 3 times the smaller. And then, of course, we got the cream puff equation right here, the green one. What is that?
X plus Y equals 6.
Yeah, I love that sum, man. That's like a freebie. Don't even know if they have to think for that one. And for the third straight problem, guess what? Substitution for the win, man. Just box up that 3y plus 4. Let's just stick it down in that other equation. What's the green equation now going to say?
4
Plus
equals 6.
Muscle through this. What's 3y plus y?
4.
Let's go ahead and take the y to the other side. What do we get?
Oh.
What? Can't the teacher growl like an angry wolf?
No.
What's that? Are you making fun of me? Oh, do we not even have to do this step? What did the problem ask us for? Did we just find the smaller number? What? No, we're done. I mean, with that example. So that's it. All I needed. Thank you for pointing that out. So I'm just done. I can just say the smaller number is 15. Boom, done. Simple pimple, eh? Thank you for catching that. I almost just wasted like a minute of my life. All right, on to example 5, and then we are done. What did you say? I hope I think I fixed this one earlier. Boy, I'm so glad I deleted the recording. It was just what a buffoon I was. Good. There you go. I'll enjoy a little bit of coffee while you record or while you copy. Coffee while you copy. Maybe I should sing a song so, to keep the recording having something on it. I could sing a little ditty or do a little drum solo on my. Just shut up. Oh, don't you get all salty with me because I growled at you like a wolf. You're the one that forgot to move the 4 over and make it negative, not me. On this salty britches. Are we there yet? Are we there yet? Good. All right, let's declare some variables. Let's let x equal the larger. By the way, you can use L and S. I just, whatever. Let x equal the. All right, stick with the consistent color coding. My first equation is underlined in yellow. The key to being good at this is to not try to read the whole sentence and tackle it all. Be a good little piece reader. So what could I start with? Okay. So I need to turn this into math now, okay? No more words. So What could I write for, say,
Will it be
this part?
something? X plus one.
I like that. Good. So let's get that out of the way. Good observation. It says, and again, if you want to kind of watch the pen as I speak and write, the sum of two numbers is. Nice. Now the right side is what comes after the word is, and that's 10 less than 3 times the smaller. What's that going to be? Beautiful. 10 less than 3 times the smaller. Nice. So far, so good. On to the green. The larger number gets decreased by 4 times the smaller. The result is, oh my God. First off, I want to circle a word in green and I want you to tell me what you think it means. It does not mean equals. And that's excellent. I'm so glad you guys are such an amazing group. You listen, you talk. I love this conversation time with you. Is does not always mean equals. How can I tell that that's not an equals is? I like that. I was not expecting that approach, but Jave is right. Like, look, I mean, this one down here, let me put red around it. This one feels more like an equal sign, doesn't it? That's an is that has a little bit more clout. What's attached to the green is that makes us think it's something else? Right. Is decreased by means minus. Right. So don't just think, okay, I see the word is as an equal sign. Like, think about the context of the word is. So let's get to it. So I'm thinking we probably will. So let's take a look first. Let's cross this first bridge and then we'll cross the second. So here we go. If you can get rid of the word if. Okay, here we go. The larger number is decreased by 4 times the smaller. The result is, that just felt like an equal sign, -46. Done. You could take all those words up there on the TV and condense them down into those 2 concise little beautiful equations. And for the 4th straight time, I feel like Parker's right. This one really looks like it just wants me to do substitution. It's a bit of a mess that I could fix it. Like you again, these are conversations some years I can't have, but I can have it with you guys. Could I move this 3y over there and make -2y? And then could I use elimination? Yeah, but I'm just going to kind of stick with what I originally heard. Let's substitute. Let's take the green equation and let's just get x by itself. If I take this equation with the stars next to it and get x by itself, what would it say?
X equals 4y minus 46.
I love it. And I'm ready to red box that sucker. And where are we going to put that?
Place the x in the top fraction.
You bet.
In the top equation.
So the yellow equation is about to get a makeover in that where it used to say x, it's now going to say blank space. So I have blank space plus y equals 3y minus 10. And what's going in the blank space?
4y minus 46.
It's always so nice after you're able to write the equations. The math almost feels like a vacation after the stress of trying to change words into symbols. The math is like, oh, relaxing. I know what to do. Let's solve this bad boy. How many y's do we get on the left-hand side if we put them together? Yeah, so this y and this y come together to make 5y. And then I'll just copy down the rest. -46 equals 3y minus 10. What do we do next? Yeah, I probably would. I like the way you think. I'm going to take this 3y and just scoot his booty over there. And, while we're at it, why don't we take this 46 and scoot his booty over there? Like, just do a little swap, and then we'll get everyone where we want them to be. How many y's will we have on the left? Yeah. Equals what? Positive 36. Very good. Because we're adding that 46 across. And divide, what do we get? Beautiful. And since we use substitution, again, the most attractive feature of the substitution is what I get to do at the end, and that is follow the purple arrow and just go put it in the box. So the box quantity would now say 4 times 18 minus 46. And what's 4 times 18? Thank you. I would have said perfect, but I was in the middle of a sip of Java. What's 72 minus 46? 26. Good job borrowing, but it's definitely 26. So at this point in time, again, just so I don't mess up my own problem again, let me go back and read the question. It says, what are the numbers? So again, so go ahead, Parker. I'm sorry. Yeah. Will you guys be sad if I don't give you your homework assignment yet? Are you okay waiting until tomorrow? So
No, we're gonna ball our eyes.
then it still worked just fine, didn't it?
That's what I mean, it's sort of easier because.
Awesome. I appreciate that. That's good. Good to know. All right. Don't be lining up at the door, okay? Yeah, I know we got about 4 minutes. I hate having 4 extra minutes, but don't be making a line like this isn't 4th grade here. So hold tight.